Greeting, who is watching this video or review. Anyway, welcome, but there is no time to waste, so I'm gonna start for now. Let's see the first graph. There is a molecule and orbit and the electrons following the orbits. The electron get energy, it will try to get more far from the nucleus, and by the time pass, or if the electron lost energy, it will get more closer to the nucleus. So, we can see this graph, when the electron get energy or lost energy. Okay, so first graph is where the electrons move. This for first orbit, second orbit, and third orbit. The first orbit has sphere, and second orbit has sphere, and 3 dimensions using areas orbit, and third for both of them and more sophisticated one. I can draw it, it's very hard. So anyway, you can see the book if you want. So, by the Schrödinger equation, you can see how the electrons move following the orbit, and this is the probability density of the electrons staying in the orbit. Okay, in short, sorry. And for second graph, guess this is the potential energy graph of the electrons. Let's guess. Here is the nucleus in the center. Okay, so by horizontal, when the electron get energy more and more, I mean the potential energy is increased. It gets more far from the nucleus. Adding energy means it gets heat right on and taking as energy electrons can get. So let's guess. I shake these waters, then the air get energy and try to escape like this. So by the far electron get energy, it have some characteristic of getting from the molecule, and if we have more energy to extract from the molecule, we call this energy by energy of vacuum. And more the molecules integrated, we can see this graph. Every portion of this sharp graph, there is a molecule of nuclear center. Sorry for being short. So let's guess. There is an Si, silicon molecule. This is a boron group. It means have 4 electrons is stereo. So when you integrate, there is 2 types for both. Integrate with third. What it means? 3 electrons in stereo orbit. So 3 and first integrate, and third want one more electrons. Hey, I want more electrons, so it gives hole and accept the electrons. So we call this as p-type junctions. P-type silicons. There is more density of the holes, and both oxidatory case. N-type means first the silicon and fifth group, like aluminum or anything else in the fourth group, fifth group. It accepts one more hole and extract 1 free electrons to get more steady. So we call this as N-type silicon, since there is more free electron densities. Okay, so so getting the next page, we can see like this: P and junction. What it means? The integrity of the P-type silicon and N-type silicons. So you see the graph. When you get into P-type, the Fermi energy level get more down to the balance band. When you get for N-type, it get more up toward to the conduction band of energy. Sorry. So we see here for the N-type, for here for P-type. So getting the steady and energy level, we can see like this graph. So when in the reverse bias, for the first 4 bias, so the P, the plus, for the N-type minus. The diffraction region get more is in expansion, and the current flow, since the barrier of the voltage get down. But for the reverse bias, the diffraction region get more smaller, and and it don't flow the current. I mean not totally, only few. So let's get first. First case, generation and recombination. By the strong electric field, the electron get energy and is trapped. And then EV means only few current can flow very weak. And for the second, the band tunneling. We heard of the quantum tunnelings, right? There is an energy war. In here we can say like this, the better voltage barrier. So by the depletion region get more closer and closer, and the energy band emits, the energy war is getting worse with is more smaller. So the electron has the probability of the passing the tunneling. And for third, avalanche breakdown. Avalanche means some thing that sorry. Avalanche means the electron get energy by the strong electron field and is trapped, but it keeps hit by the molecule of silicon, and by this impact, another electron move, and the same pattern happens in stereo. So when it keeps, the silicon type will break down. So we call this as avalanche breakdown. So you can see this graph. This is when avalanche happens and general diode current. And this is when for bias, we can see this the current is more increasing when the voltage is getting increased. But in the reverse bias, it's not. Okay, then the third page. For this page, we are thinking about the conductor. I mean some like metal, aluminum, anything else, and the junction of the N-type. So we know the metal have every electron in itself. What it means? Yes, the the balance of the energy band and the conduction energy band is interrelated some portion, and between them there is a variable energy. So free electrons is behaving inside this portion. So you can see here what I said. And guess. The first, this picture is meaning that the metal is spec as P-type, not silicon, but somewhat a portion P-type, and here the N-type silicon. When it meet, the silicon's energy band changed, and burst. When for biased, the energy barrier voltage down and current flow. Same as the previous one of the p-n junctions, but for reverse bias, the energy barrier, voltage barrier is more increased and the height is more upper. So, likely the p-n junctions, reverse bias, the current can flow well. But of course, there is some examples that the current can flow. For first, when we get the reverse bias, there is a strong electric field inside the depletion region. So first, the region get more strong energy by the electric field or the heat, like anything else, by its heavier power. So it gets the energy, and the electron overcame this voltage barrier. This is the first case. We call it the thermal emission. For the second, thermal field emission. This is the integration of electronic field, in short, tunneling, and the thermal. And the third, there is no thermal occursion, but there is only by tunneling. So what it means? The depletion region is getting more shortened and shortened. So with this shortened, then there is more probability of the electrons passing through this region and going to another side of the type. So this is called the same as the quantum tunneling. Okay, till here, this is my review. Thanks for watching.